Do you know what indices are? Indices are numbers that show the number of times a base is to be multiplied by itself. Another name for indices is exponent. Let me give you an example. Look at this. We have something like 2 to the power 3. 2 to the power of 3. Or rather, we can also say that 2 raised to the power of 3. Now, this 2 raised to the power of 3, this 2 can be regarded as the base, while this 3 is the index. Now, index is the singular form of indices. Indices is the plural. Index is the singular. Now, this 2 raised to the power of 3 means that we have to multiply 2 by itself 3 times. That's the meaning of what? Of 2 raised to the power of 3. 2 raised to the power of 3. 2 times 2 times 2. Of course, this will give us 8. Now, whenever we are carrying out mathematical operation involving indices, we have several laws that guide us. We call them laws of indices. First law of indices, we call it multiplication law. Let's have A. If you have A raised to the power of m multiplied by A raised to the power of n, we're just having a representation. Whenever the bases are the same like this, I have a multiplication in between them. You just pick one of the bases. We have A, then raised to the power of this m, then the multiplication sign changes to addition sign. Then we have what? The second power, which is n. It means that whenever you have multiplication between two indices having the same base, then you pick just one of the base, then you add the exponents, you add the powers. An example of this, let me say, if you have something like 2 raised to the power of 3 multiplied by 2 raised to the power of 2, this is going to give us 2 raised to the power of 3 plus 2, and that gives 2 raised to the power of 5. Very good. That's the first law. Now, the second law is called quotient law. Quotient law. Of course, quotient simply means division. Now, when you have something like A raised to the power of m, A raised to the power of m divided by A raised to the power of n. Of course, this is multiplication, this is division. So whenever you have the same base like this, just like I explained earlier, you have the same base and you have division in between the two indices. What happens? The division changes to negative sign. We have A raised to the power of n minus n. An example of this, if you have 2 raised to the power of 3 divided by 2 raised to the power of 2, this gives 2 raised to the power of 3 minus 2, and then the final answer will be 2 raised to the power of 1. Let's go to the third law. Now, the third law, we call it power of multiplication law. A, B raised to the power of n. AB, of course, AB means A multiplied by B. You see, whenever you have two alphabets like this in mathematics, it means that there's a multiplication between them. So AB in brackets, then raised to the power of n. This is going to give us A raised to the power of m multiplied by B raised to the power of m. Now, what happens here? It means that both the A and the B own this power. A raised to the power of m, B raised to the power of m. It can also go either ways. Of course, whenever you have x equals to y, it also means y equals x. X equals y, y equals x. The left hand side equals to the right hand side. It also means that the right hand side equals to the left hand side. So when you have AB raised to the power of m
It means that the A will be raised to that power, then multiplied by the B, also raised to that power. Let me give you an example of this. In between these 2 and x, we have a multiplication, even though it is not written. We have a multiplication in between 2 and x. So what do we have? We have 2 raised to the power of 3 multiplied by x raised to the power of 3. And of course, 2 raised to the power of 3 means 2 times 2 times 2, like I explained earlier, which will give us 8. Then we have 8, then x raised to the power of 3. That will be the final answer for that. That's power of multiplication law.
The fourth one is the power of a quotient law. When you have A over B in bracket raised to the power of M, we can also call this A divided by B. You see that you say A divided by B or A over B in bracket raised to the power of M. This means that this power outside the bracket belongs to both the numerator and the denominator. So what do we have? We have A raised to the power of M divided by B raised to the power of M. An example of this, let's say we have let's say 2 raised to 2 divided by 3 in bracket, then raised to the power of 3. What do we have? We have 2 raised to power 3 divided by 3 raised to power 3. We know that 2 raised to the power 3 means 2 times 2 times 2, and that gives 8, divided by 3 raised to power 3 means 3 times 3 times 3, and that gives 27. Let's go to the fifth law of indices. The fifth law of indices is called power of the power law. A raised to the power of M inside a bracket, then raised to the power of M. This is power of the power. Power inside the bracket is M, while the power outside the bracket is N. What do we do? In this case, we just say that A raised to the power of what? We multiply the powers, because of course bracket actually means multiplication. So we have a bracket in between a power and another power. That means we're going to have what? A raised to the power of M multiplied by N. And what is N multiplied by N? Mn.
N. Exactly. An example for this, let's say we have something like 2 raised to the power of 3 inside the bracket raised to the power of 2. We're going to have 2 raised to the power of 3 multiplied by 2, and that gives 2 raised to the power of 6. 3 times 2 gives 6. So we have 2 raised to the power of 6. What is 2 raised to the power of 6? That should be 64. Yeah, if you multiply 2 by itself 6 times, it's going to give 64. Let's go to the sixth law of indices. The sixth law of indices, we'll call it the fractional index law. Let me go with negative index law first. Negative index law. Negative index law. Now, what do we mean by this? It means that our index, that is our power, is going to be a negative number. An example is if you have A raised to the power of minus M. A raised to the power of minus M. Now, when you have A raised to the power of minus M, what happens? This negative sign, this is one of the laws of indices. It's a law which you have to abide by. So this negative sign becomes 1 over. It is just the negative sign that becomes this 1 over. Then what do we have left? A raised to the power of M. So we're going to have 1 over A raised to the power of M. Let me give you an example of this. An example, if you have let's say 2 raised to the power of minus 3. 2 raised to the power of minus 3 gives 1 over 2 raised to the power of 3, and that gives 1 over 2 raised to the power 3 is 8. So we have 1 over 8.
The seventh law of indices, we call it the zero index the zero index law. This means that the exponent or the power rather has to be 0. Now let's have this. If we have a raised to the power of 0, it gives 1. This means that any non-zero integer raised to the power of 0 gives 1. We have 1 million raised to the power of 0, it gives 1. Now let's go to the 8th law of indices. We call it the fractional index law. Fractional index law. Fractional index law. This means that the power is going to be in the form of a fraction. Let's say a raised to the power of m over n. Do not mistake this for a mixed fraction. This is not a mixed fraction. The law states that you raise the number to the numerator power and take the denominator root. I repeat, you raise this number to the numerator power and you take the denominator root. Now what do we mean by this? The nth root of a raised to the power of m. Now you understand this better. Let me give you examples. I'll give you 3 different examples to understand this better. The first one, if you have let's say 4 raised to the power of 1 over 2. 4 raised to the power of 1 over 2. Do not mistake this for 4 whole number 1 over 2. Look at the difference. The 4 is way bigger than the 1 and 2. But look at this. So this is mixed fraction. This is 4 whole number 1 over 2. While this is 4 raised to the power of 1 over 2. And let's check this. According to the law, we can see that the numerator in this case is 1, while the denominator is 2. So what do? We raise this 4, we raise it to the power of 1, then we take the square root of 4. You know that square root, you do not need to put this 2. Whether you do it like this or you write it this way, it's still the same thing. You do not need to put the 2. But whenever it is any other number, you must write it, you must show it. But for 2, you do not need to put it because this is still the same thing as writing this. This is a square root, this is a square root. Or we also call it radical 2. Radical 2. So we know that in this case, the square root of 4, of course, 4 raised to the power of 1 is 4. Any number raised to the power of 1 is that number. It's still one of the laws of indices, but we do not really include it. So 4 raised to the power 1, 4 raised to the power 1 means 4. Anything raised to the power 1 means that 8. So 4 raised to the power 1 is 4. So what is the square root of 4? The square root of 4 gives 2. Another example for this, so that you understand better, let's say 8 raised to the power of 1 over 3. Now let me quickly make you understand something. Whenever you are finding the square root of a number, the answer must be a number that when you multiply it by itself twice is going to give you that number in the root. Look at 4. The square root of 4 gives 2 because 2 multiplied by 2 gives 4. Do you understand that? Yeah, I'm sure you understand. I'm sure. So yeah, this 8 raised to the power of 1 over 3, what are we going to have? We're going to raise the 8 to the power of the numerator power, which is 1. Then we'll find the cube root. Of course, we know that 8 raised to the power 1 is still 8. So what do we do in this case? We say cube root of 8. Cube root of a number, you must get a number in which when you multiply it by itself 3 times, it's going to give you the number inside the root. So what is the cube root of 8? Of course, it's still going to be 2. Because 2 multiplied by 2 will definitely give you 8. You can check it out. So that means the cube root of 8 is 2. Now, I'll give you the last example, which is, what should I use? Let's use something like 8 raised to the power of 2 over 3. I hope it's a reasonable example. Now, if you have 8 raised to the power of 2 over 3, in this case, the numerator is not 1. That's why I'm using this example. Now, the numerator is 2, while the denominator is 3. I'm still going to do the same thing. We'll raise this number to the power of the numerator. We raise the number to the numerator power, and then we find the what? We find the denominator root. So what do we do in this case? We are going to have cube root of 8 and what? Then don't forget you raise it to the power of what? You raise it to the power of 2. So how do we do this? Plus 8 squared is 8 times 8, which gives 64. So what do we have? We have cube root of 64. Now what is the cube root of 64? It means a number which, when you multiply by itself 3 times, must be able to give you 64. And what is the answer? That should be 4. Because 4 times 4 times 4 gives 64. So our answer is 4.
It's the law of exponential equation. The law of exponential equation. Now, what do we mean by exponential equation? Exponential equation actually means an equation involving indices. An equation involving indices. Of course, we know that equation means that there must be a left-hand side, there must be an equality sign, and there must be a right-hand side of the equality sign. Something like something equals another thing. Now, let me give you an example. If you have A, this particular law has 2 parts, and I'm going to give you the 2 parts. So I will call it 9A and 9B. So for the 9A, if A raised to the power of X is equal to A raised to the power of Y. Now what do you notice? You will notice that the bases are the same. We have base A, we also have base A. But the powers are different. This is X and this is Y. But remember that equality sign means that the left hand side must be equal to the right hand side. So what does this mean? It means if A is equal to A, then X must also be equal to Y. If the bases are the same, the powers must also be the same. So what does this mean? It means X is equal to Y. So if A raised to power X equals A raised to power Y, then X must be equal to Y. Then the second part, if X raised to power A is equal to Y raised to power A. Now look at this. What do you notice in this case? You notice that the bases are different, while the powers are the same. It's still the same thing. When the bases are the same, the powers must be the same. When the powers are the same, the bases must be the same. So if A is A, then X must also be equal to what? Y. Then X is equal to Y. This is the last law of indices. Now that I've given you all the laws of indices, all you're going to do for me and for yourself is to go back to the beginning of the video, watch it slowly all over again, master all the laws, and prepare to meet me in my next post to start solving questions on indices. Thank you and God bless you. Do not forget to like, comment, and share my post. Bye.